Hello everyone and welcome to Precalculus. Today we're going to be doing section 7.1 and 7.2, which is linear and nonlinear systems of equations. So first we're going to solve this system. We're going to do it both algebraically and by graphing. But before we do anything, I hope you are taking a look at that and thinking clear fractions first. I know I'm always preaching this, but literally with a clean swoop of an 8, you can make this so much better. 8 times a half is 4x, 8 times an eighth is 1, and 8 times 3/8 is -3. Look at that equation, so much nicer. And then I'm going to move the y to the other side and the 3 to this side, and I have a nice equation that I can graph easily. I know that it goes through the point 0, 3. If x is 0, y is 3. And I know it has a slope of 4. So I can go up 4 and over 1, which I can't actually do. So I'm going to go down 4 and then back 1. Down 4 and back 1 so that I can draw a nice line. My other equation, I'm going to get y all by itself on one side. And then I'm going to divide by 3. Now, I could divide each individual portion by 3, but I do not want you to try to start this graph at 5/3. I'd really rather you keep this as a single fraction, at least while you're trying to pick one good point. You can use this slope of 2/3, but don't try and start at -1 and 2/3 and then go down to and over 3. It's not going to make an exact graph. But you can find one good point. So you're just trying to find a number that when you multiply by 2 and then add it to multiply by -2 and then add it to -5, it's going to be divisible by 3. So right away, let's see if I do 2, right? So 2 times 2 is -4. -4 minus 5 is -9. So -3. So 2 and then -3. Now that I have one good point. If you make a graph and none of your points actually fall where they're supposed to, I'm not going to give you credit for it. But now I can go down 2 and over 3, down 2 and over 3, back 3 and up 2. Oh, I found my point of intersection. Back 3, up 2, back 3, up 2. And I can draw a nice line on that. And like I said, I found that point of intersection. They intersect at the point -1, -1. That is called the solution to a system. So first off, a system of equations simply means more than one equation. And the solution to a system of equation means the point or points that satisfy every equation in the system. That is the algebraic definition. So if I put -1, -1 into this equation, it should work. And if I put -1, -1 into this equation, it'll work. It's the only point that works for both of them. That's what makes it a solution. But graphically, it's the point of intersection. So there's two ways to think about it, graphically and algebraically. So how would we have solved this problem algebraically if we didn't want to graph both lines? I actually would have started pretty much the same. I would have gotten this 4x plus 3 and then is equal to y, and then I could plug that in for y. So 2x plus 3 times 4x plus 3 is equal to -5. That would give me 2x plus 12x plus 9 is equal to -5. 14x is equal to -14. X is equal to -1. Plugging a -1 back into here, 4 times -1 is -4 plus 3 is also -1. So why are we graphing then? Because let's agree, It's easier to do it algebraically. Honestly, the graphing is just to practice all the graphing that we've done this year. So we're going to kind of kill two birds with one stone here. We're going to practice our algebra, but we're also going to practice our graphing. And this chapter is going to prove to just be a really strong end to the year to make sure all your precalculus is where it needs to be. All right, there are three methods for solving a system of equations. Like I said, there's graphing, which nobody does that to actually solve. The easier way is something algebraic. So just now I used substitution, but you may remember a method that has several different names. We're going to call it combination. You might have heard it called the addition method or the elimination method. That would have been if you had taken these two equations. First, let's just switch this back. So this would have been multiplying through by 8. 4x minus y is equal to negative 3. And then this one, 2x plus 3y is equal to negative 5. You may remember multiplying this one by 3 on both sides to give me 12x minus 3y is equal to negative 9. And then adding the equations, which is why sometimes it's called the addition method. But we do that to eliminate the y, which is why it's called the elimination method. And then your book happens to call it combination. So this is the third method. You're allowed to use whichever method you want. Okay, I'm not going to dictate which one you have to use. When you're solving a system of linear equations, that means that they're just lines. There's three different types of solutions. One solution, where they intersect. No solutions. The lines are parallel. Or there's an infinite number of solutions, which is when the two lines coincide. That means that they lie right on top of each other, coincide. But now there's going to be way more solutions to consider. And it really depends on which equations are in the system. So the key is going to be for you to think about the graphs of each system, even if you don't graph it to solve the problem, even if you don't actually solve it graphically. You could have two circles that intersect in two spots. You could have two circles that don't intersect at all. You may get two circles that just barely touch, and they have only one point in common. You could have a parabola and a line that don't intersect, or a parabola and a line that intersect twice, or maybe a parabola and a line that intersect exactly once. Now these still have 0, 1, or 2 solutions, but what if you end up with a circle and a parabola? That could have 2, but it could have 4. So these problems are definitely going to get more complicated. 4 possible solutions. Or there's still the possibility that you have a circle and a parabola that don't intersect at all. So having a sense of the graph will be super important. First example. So like I said, we can solve this algebraically, but I want to make the graphs first so I have a sense of what they look like. So this equation is a parabola. I recognize it because just the x is squared and not the y. I'm going to rewrite it as x squared plus 4x. I'm going to bring the 5 over and put the y on the other side. You guys have learned several ways this year of graphing. One is to find the vertex, which we do by doing negative b over 2a. This is actually not my preferred method. Mine is factoring. So I would change this to x plus 5 times x minus 1, which means that the x-intercepts, so factoring finds the x-intercepts, is going to be negative 5 and 1. So I've already got 2 points. And it actually also helps you get the vertex without doing negative b over 2a, because the vertex will always, the x-coordinate of the vertex will always lie halfway between the intercepts. So now I know the axis of symmetry is at x is equal to negative 2. So the vertex must be negative 2 comma something. So if you plug a negative 2 in, negative 2 squared plus 4 times negative 2 minus 5 is negative 9. And I can go ahead and plot that. But no matter which of them you do, you should always just take a minute and find the y-intercept. It gives you another point super fast. When x is 0, y is negative 5. So hopefully there's at least one of you that's saying, wow, this seemed so hard back in October. Remember, you've gotten smarter and stronger since then. So hopefully this little review of how to graph a parabola makes more sense now than it did months ago. Remember, we can use symmetry. I have the y-intercept. I can use symmetry to also get that point right there. And here's my parabola. So my other one is a line. I'm just going to rearrange it a little bit. 2x plus 3 is equal to y. Just like before, finding the y-intercept is always on your list of things to do. So it's 0, 3. And with a line, as soon as you have one point, any point, you can just use slope. So up 2 over 1, up 2 over 1. Oh, so I think I probably found that point of intersection, even though I didn't actually originally graph my parabola that high. And there's the other one. So you just found the answer by graphing because it actually fell on that point. But sometimes, of course, you're going to get things that land at 1/8, comma 2/3. You're not going to find that. So we are going to go over the algebraic techniques as well. So it looks like 2, 7 is one of the answers, and negative 4, negative 5 is the other. How would I have solved this algebraically? I think I would have used substitution. So now that I have y equal to this, I have x squared plus 4x minus 5 is equal to, instead of y, I'm going to make it equal to 2x plus 3. I see an x squared in my equation. What do? I set it equal to 0, and I factor x plus 4 times x minus 2. And so x is either equal to negative 4 or 2. Now remember, don't stop there. The answers are an ordered pair. There's an XY combination that works for the first equation and also works for the second equation. Graphically, that made more sense, but make sure you do it even if you solve your problems algebraically. How would I have gotten this y? You just plug it into either equation. Obviously, I would choose the line. It's a little easier. Number 2, I have another parabola that's going to be down, and then I have a quartic function, which means it's going to make a W since it's ending up. This one has a y-intercept of 2, and this one has a y-intercept of 2. So look at that. I already know one of the points of intersection. So let's graph the parabola first. This time you can just not even find negative b over 2a or factor or anything. This is just a parabola that has been moved up to but not left or right. So it's going to start there. I know it's going down, and normally I would plot 0, 0, 1, 1, 2, 4 from that new origin, but instead I'm going to multiply everything by negative 2. So the points that I'm going to plot are 0, 0, 1, negative 2, and symmetry, so on the other side, and then 2, 2, 4, 6, 8. So this is going to be my parabola. And then my other one is, like I said, quartic. So I can factor it. I'm going to take out the 2, x to the 4th minus 2x squared plus 1. And it has something that we call quadratic form. So it's still factorable if you just think of these both as x squared and x squared rather than x and x. And then it's minus 1 and minus 1. So I get 2 times x plus 1 times x minus 1, x plus 1, x minus 1. And you may remember that whenever you have a 0 that repeats, then it bounces at that point. So I know its y-intercept is also this 0, 2. I know it has a bounce at -1 and another bounce at +1. So it must come down and then go up and then come down and go back up again. It looks something like that. Without doing any algebra at all, I can see that my answers are -1, 0, 0, 2, and 1, 0. But since you are most unlikely to actually do this by graphing, of course, we're going to do it by algebra. So I would use substitution method. I'm going to plug this in for y right here because that's what y is equal to. So -2x squared plus 2 is equal to 2x to the 4th minus 4x squared plus 2. I see not just an x squared, but any higher power of x in my equation. What do? I set it equal to 0, and I factor. Bringing that over gives me -2x squared, and bringing this over actually makes it go away. So don't forget about factoring out first. It's often forgotten, and it really gives people a lot of trouble, but if you just take that 2x squared out, this is not that bad a problem. You just get x squared minus 1, and that gives me x plus 1, x minus 1. So what x's will make this equation equal to 0? If x is equal to 0, if x is equal to -1, and if x is equal to +1. You would have to change them to ordered pairs. You can use either equation, so I would use the top one. It's a little easier. When x is 0, you get 2. When x is -1, you get 0. And when x is 1, you get 0. And those would be your 3 answers. Number 3, y is equal to the natural log of x. All right, that was chapters ago that we graphed natural log of x. So the thing I really want you to know about natural log is its basic shape and where it crosses. So it crosses at 1, 0. Just like you know anything to the 0 power is 1, that's probably something that's pretty firmly in your head. You need to know that the natural log of 1 is 0. Remember that exponential functions and logarithmic functions are inverses of each other. That's how you can remember these two important facts. The other thing you need to know is its general shape. So it has an asymptote there, again, just like the e function or any exponential function crosses at 0, 1 and has an asymptote. I did draw it, but it was a little hard to see. Here, the logarithmic functions are in reverse. So you don't even have to come up with another point. This is basically what it's going to look like. And then this one is y is equal to -x plus 1. You could have written 1 minus x, but most people put it here. Our slope is -1, and I always find the y-intercept when x is 0, I get 1. Ah, there we go. I have found one of the points of intersection. Could it cross more than twice? Sure. If you have a line that goes like that, it could definitely cross more than once. But if you have a line that goes in this direction, then it's not going to cross more than once. What is our line? Our line has a negative slope. From the one point I know, I can go down 1 over 1, down 1 over 1, and I can see that I have found my only point of intersection. So the next question is, how would you have done this algebraically? So you would use substitution. You would put the natural log of x in for y. X plus natural log of x is equal to 1. And then do you remember how we get rid of a natural log? We isolate it, and then we take the e of both sides. We exponentiate. E to the ln of x is equal to e to the -x plus 1. That gives me x is equal to e to the -x plus 1. Oh, but now I have x stuck as the exponent. That's not good. How do we undo an e? We natural log. Oh, no. All right, you can see what's happening. We're going to be in some kind of an endless loop. The bottom line is you don't know how to solve these kinds of problems algebraically. This is above what you have learned this year. So this one has to be done graphically. So just when you thought you were going to escape knowing how to graph natural logs, there you go. you are going to know how to do that. Fortunately, it's not the majority of problems. The majority of them are going to be lines and polynomial functions. So hopefully you recognize right away that this one is a line, and the top one is some kind of a cubic function that ends up. It has a y-intercept of 4. Always find that y-intercept. It's so easy. Oh, and this one has a y-intercept of 4. Guess what? We just found one of the points of intersection. Let's graph the line first because it's easy. 0, 4, and then it has a slope of down 2 over 1. So we can graph that. And then our cubic function. So I actually don't know how to graph that anymore. I can't factor this. I can't, I really can't find anything for it. I could try to find some zeros, but I really don't know how. So this one, we decided we had to do it graphically. We couldn't do it algebraically. And this one, you might get a problem where you're like, I don't know how to graph that. That's when you switch to algebraically. So what you're doing is you're creating a toolbox and figuring out which method is going to work for which problem. So again, I'm going to use substitution. I'm going to substitute this in for y because y is negative 2x plus 4. I see an x to a power in my equation. What do? I set it equal to 0 and I factor. So you might be thinking, but a minute ago, you told me that I couldn't factor. Well, these problems are contrived. They're meant to make you successful. So now that this is plus 0, you actually can factor because you can factor out first. Okay, this one, not so much. This one, take out the x and look at that. Now you have a squared function, which I know you know how to factor. X minus 2 times x minus 1. Your three answers that would cause this equation to be equal to 0 would be if x is 0, if x is 2, or if x is 1. So let's go ahead and find the y coordinates. Well, we already know this one. If x is 0, y is 4. If x is 2, so when x was 2, it's 0. I can see that one. And when x is 1, it's 2. These are the points of intersection. So this, and this. So what does this graph look like? It's hard to know exactly, but you do have to make sure you draw it coming up. If you want, you can go right to that point, but maybe that's not actually the high spot. And then you need to have it coming down and then going back up. I don't know exactly what it looks like, but it must look something like that because it definitely passes through these 3 points and it definitely ends up because it's cubic. Next one, number 5. Ooh, square root function. So we haven't done one of those yet today. So a little review, that square root function's general shape looks like this. And the points I want you to memorize are 0, 0, 1, 1, 4, 2. 0, 0, 1, 1, out 4, and up 2. But this one has been moved to the right one. I'm just going to mark over here. This is just the parent graph. So ours has been moved to the right one, and then that's my 0, 0, my new origin, 1, 1, 4, 2. And if I had room for it, which I actually do, I can do 9, 3. So 9, 3 would put me there if you want to make sure you get that good shape all the way to the end. And then this other one is going to be a line. So I'm going to move the y to the other side and the 1 to this side, and then divide by 2. So remember that before you write this as y is equal to 1/2 x minus 1/2, which is great because now I can see the slope. I do not want you to try to start at 1/2 and then go up 1 and over 2 and be in the middle of points like that. Instead, try and think of one good point while it is still in the form x minus 1 over 2. So pretty much any odd number is going to do it for you. So let's just say 3. When x is 3, 3 minus 1 is 2 over 2 is 1. So at 3, it's 1, which looks right from what the other points I already started to plot. And And then I can use my slope, up 1 over 2, up 1 over 2. And I can keep doing that backwards. And I can check my y-intercept. I thought my y-intercept is negative 1/2. And sure enough, it's definitely going to go through that point. But this is more exact when you actually find one good point. So take just a minute and always find a good point. I can see from here what my answers are. I can see the 5, 2, and I can see the 1, 0. How would you do this problem algebraically? I don't know. This one might be one where graphing is a little bit easier. So I do have, I think I'm going to use substitution with the x. X is equal to 2y plus 1 just by moving the 2y over, because y gave me this fraction, which isn't very nice. And then I have the equation y is equal to the square root, and I'm going to put the x right in there. 2y plus 1, that's what x was, minus 1, which gives me y is equal to the square root of 2y. How do I get rid of a square root? I square both sides. That gives me y squared is equal to 2y. I see a y squared in my equation. What do? I set it equal to 0 and factor. Don't forget about factoring out first. Y times y minus 2 is equal to 0. Y is equal to 0 or 2, which I already got. Y is 0 and 2. And you'd have to go back and solve for x. So I want to make one little note here for a minute, and that is I'm always trying to point out common mistakes. From this point right here, a lot of times people divide both sides by y, and then they get y is equal to 2. When you divide both sides by y, instead of setting it equal to 0 and factoring, you eliminate a possible answer. You've literally divided an answer away, which for us is not a problem because we graphed it. But I have a feeling you're not going to bother to graph this one. And if you don't graph it and you think the only answer is 2, then you're only going to get half the points because you'll only have found half the solutions. So pointing out common errors, this is one of them. Number 6. By the way, if you're still watching this video, you should really try this one on your own. This is a line and a parabola. This line is going to be y is equal to x plus 4. Its y-intercept is 0, 4. Its slope is 1. And so it looks like this. If you were doing the parabola, then again, I would set it equal to y. And I get y is equal to negative x squared plus 3, which means it's a parabola that's going down but has been moved up 3. And it's going down. So instead of 1, 1, I'm going to do 1, negative 1, 2, negative 4, 3, negative 9. And of course, the symmetrical one's over here. What is the answer to this? What is the point of intersection? There is none. So we write no solution. That is the symbol for no solution. Now the question is, what would have happened if you had done this algebraically? So let's just say you'd use substitution. You change the line to y is equal to x plus 4, and then you put that into your equation. So plus instead of y, plus x plus 4 is equal to 3. You would have gotten x squared plus x plus 1 is equal to 0. You couldn't factor. So what do you do if you can't factor? We do have a backup plan. Do you remember what it is? Use the quadratic formula. So you're going along, doing the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2 times a. And this gives you a negative under the radical, which means the answer is imaginary. So it's only in your imagination this has an answer. Okay? You can't take the square root of a negative number. So if you'd been doing this algebraically, then you would have had to decide, do I trust that there's no solution, or should I quick graph it and make sure? But this is your key right here, that there's no real solution. Number 7. This equation is the first time we've done one of these today. This is the equation for a circle. It has not been moved left or right. It could be moved left or right. Then it would look like this. Y minus k squared is equal to r squared. But ours is right at the center, and its radius is 5. So you can make a point at 5 all the way around, and then do your best to draw a circle. Try not to have it look too egg-shaped. I'm usually a little better at it if I do it as 4 separate quarters. And then my next one is a line. 3y is equal to negative x plus 15. Divide by 3. Now this time, when I divided individually, it was okay because I got a whole number there. I didn't have to stop at this step and try and get one good point. Fortunately, it came out to a nice number, so I can get a good point easily by making x be 0. All right, so there you go, 0, 5. I already know one of the points of intersection, and this is going to go down 1. Ooh, and over 3. I think I just found my other one. If I'm not sure, though, that point is it looks like it's on my circle, but if I'm not sure if it's on my circle, then you could always test it algebraically. So let's find the algebraic answer. Again, I'm assuming that people are not going to choose graphing as their first choice. I think that they're going to choose algebra. That's why I keep doing them algebraically. If you did that, then first I would use substitution to get x. Sorry, I had a little pen difficulty. X is equal to negative 3y plus 15. That's the easiest one to get alone, unlike when we were graphing it, where I got y alone. And then I'd plug that in. So in my x squared plus y squared is equal to 25, I'd replace this with negative 3y plus 15 squared plus y squared is equal to 25. Please, please, please do not forget that negative 3y plus 15, the quantity squared, is not 9y squared plus 225. You cannot distribute this square. Nope. Instead, you have to multiply it all the way out. Negative 3y plus 15 times negative 3y plus 15. Okay, it's a little bit of a pain, but you got to do that step. All right, that gives us 9y squared. 3 times 15 is 45. There's 2 of them, so minus 90y plus 225. I definitely preferred graphing. This is a lot of work, right? I get 10y squared minus 90y. I bring over the 25 plus 200. I've set it equal to 0. I'm going to factor, but for the, I don't know, what, 5th time today? Factor out first. It'll make you happy. So I take out the 10, and now I just have y squared minus 9y plus 20. So much easier. I can see right away, oh, 4 and 5. It's such a great way to do a problem. So y is equal to 4 or 5, which is what I was already thinking, right? That y was 4 and y was 5. I do need to list my answers as ordered pairs. Obviously, you know at 5, the x is 0. But how can I find it for the 4? If you didn't make the graph and can't just see that it's 3, you can plug it into either one of these equations. So x plus 3y, we wrote it as negative 3y. So x is equal to negative 12 plus 15 is equal to 3. Okay, so 3 and 4 are my 2 answers. All right, number 8. I hope this is proving to be a good review of graphing and other things that we've done this year. Here's another circle for you to, 2 circles for you to try. This first one is the same as the last one. So we'll go ahead and draw it again really fast. It has a radius of 5, and it has not been moved off the center at all. This other one, though, has been moved to the right 8. So way over here, but it hasn't been moved up or down. And then I don't actually know, oh, that's not a perfect square, but I know that 6 squared is 36 and 7 squared is 49. So I'm going to draw it at 6.5. 1, 2, 3, 4, 5, 6. A little over there. 3, 6.5, 2, 4, 6.5. So it's going to look something like this. Am I going to be able to find this one? That was terrible. Am I going to be able to find this one graphically? No. But at least now I have a sense of what the answer is. And since this is actually going to be a point of intersection, I'm going to redraw that curve. So I have a sense of whether or not my answer is right when I get there. I mean, you could graph this and say, ooh, is there any chance it goes right? Like, how good did I draw that? So I'm going to write it down as my prediction. 3, 4. And you could just test this point in both of them. 3, -4. And if it works, you don't have to do the algebra. But because I want to show you how to do the algebra, I am going to do it. So I would use the substitution method. Instead of getting y by itself, I'm going to get y squared by itself. Y squared is 25 minus x squared. And I'm going to put that in right here. X minus 8 squared plus 25 minus x squared is equal to 41. I do have to expand this. Please do not write x squared minus 64 or x squared plus 64. It's x squared minus 16x plus 64. I actually don't need the parentheses anymore because I did their job. Plus 25 minus x squared. Ooh, do you see what happened? This is so great. My x squareds canceled. Normally, I see an x squared and I have to set it equal to 0, but they went away. So now I just have minus 16x is equal to, this is 89. So I'm going to subtract 89 from both sides, and I get negative 48. Divided by negative 16 is 3. And sure enough, the x coordinate both times is 3, as I predicted. How would you get the y if you hadn't been doing this graphically? You would write 3 squared plus y squared is equal to 25. Y squared subtracting 9 from both sides is 16. Y is equal to plus or minus 4. Of course, if you forget your plus or minus, then you'll have done a really hard problem and not gotten all the answers. So the answer is algebraically 3, 4, and 3, -4. So I hope I've showed you at least a little bit on the benefits of being able to graph well. All right, last graphing problem. These are both lines, but the purpose of this one is to make you practice your fractions again. Multiply both sides by 8, which changes this to 4x minus y is equal to -3, which I'm going to change to 4x plus 3 is equal to y. So its y-intercept is at 3, and its slope is up 4 over 1, which I can't quite reach, so I'm going to go down 4 and back 1. And that's that line. This one is also a line. I'm just going to move the 4x to the other side. So it also has a slope of 4, and it's actually identical. It is the same exact line. So what are its points of intersection? All points. It intersects everywhere. But here's the key. If you remember this from Algebra 1 or Algebra 2, you can't just write, there are infinite solutions. That's true, but it's not acceptable because it's not every solution. 10, 1 isn't there. -5 isn't there. There's tons of points that are not solutions. You still need to express your answer as an ordered pair. So if in Algebra 1 or Algebra 2, some teacher let you just write, there are infinite solutions, That's not going to be acceptable this year. Instead, you have to tell me what the solutions are. But this is very easy. You're pretty much just going to write A, meaning whatever A you pick. So pick any A, pick 1. How would you find the y coordinate if you knew or you wanted to have 1 be the answer? You'd plug it into this line. So you'd do 4 times x plus 3, 4a plus 3. That's how you can appropriately express the answers. So if a is 1, then 7 is on there. That's one of these infinite solutions. If a is 0, it's 3. That's also one of the infinite solutions. If a is -1, when you put a -1 in here, you get -1. That's one of the infinite solutions. Okay, so the only thing we have left are the word problems, so that'll be on part 2 of this video. Meanwhile, have a great day.